All right, so this is the extra practice, or this is the homework for 7-3. So for this one, you've got secant and you've got tangent. You have to replace one of them. And we know tangent squared plus 1 equals secant squared. So you actually can replace either one here because they're both squared. So which one did you replace? Secant, you put in 1 plus, or tangent plus 1. Okay, so 3 times tan squared plus 1 minus 2 tan squared x minus 4 equals 0. Distribute, so 3 tan squared x plus 3 minus 2 tan squared x minus 4 equals 0. Combine your like terms, so there's 2 tan squareds. 3 minus 2 is just 1 tan squared x. Positive 3, negative 4, which would be minus 1, equals 0. Add the 1 to the other side, and I get tangent squared x equals 1. And then we square root both sides, making it plus and minus. So I'm looking for where tangent is both positive and negative 1. So I would go to the unit circle. I use only the top for tangent because this isn't a restricted interval. Positive 1 happens at the pi over 4, so that's 1 pi over 4. And negative 1 happens at 3 pi over 4. That's the other one. And then because it's tangent, we add n pi, because it happens every half circle. Yeah. No, you just don't need it. Right. Huh? I mean, because it's not wrong, it's just redundant. You're just saying the same thing twice. Yeah, and as long as it's not multiple choice. Like if it was multiple choice, which we haven't even done your test for next week, so I'll know more when we do that, when we meet about it. But if it was multiple choice, you would not see the other two. Yeah.
On the answer key, none of the answers have the plus and pi. Is that like a mistake?
It would just be, so the answer key that I'll post this one today, which is the worked out one, and they have that. The only time it wouldn't be there is if it gave you the interval and it didn't. So it should have the plus n pi and the plus 2 n pi. So I'll post these today, which has the worked out solutions, and it has the interval on there. Okay, so then 7. So this was one of the multiple angle ones, and I know it's different because there's something attached to the x there. So I would, different colors, sorry. I would move the square root 3 over 2 to the other side, and then I look for the solution before I worry about the 2x. So I want to know wherever sine is positive root 3 over 2, sine is positive in the top, and root 3 over 2 at the over 3s. So pi over 3, 2 pi over 3, and I would add 2n pi because it's sine. And normally that's my answer, but it's 2x equals that, not just x. So then I would take and divide both sides by 2, and when I divide the angle by 2, I also have to divide the interval by 2. So this is like pi over 3 times 1/2, or pi over 6. The 2's cancel, plus n pi. This would be times 1/2, so these would cancel, pi over 3 plus, and these cancel n pi. And those are your answers. So when it's a multiple angle, when you've got something attached to your x, whether it's multiplication or division, because that was the other option, you have to make sure at the end you change the interval as well as the angle.
Is there anyone with division?
I actually don't know. I don't remember. I'll look at it. I gave an example on the notes on Friday that's division, but I can definitely make sure there's one on the...
But you didn't post it on Friday, so I watched the 2021.
Oh, I didn't post it on Friday. So 8 says you've got 4 tan squared, theta plus 5 tan theta and equals 6. So as soon as you see the tan squared and the non-squared, this is like your hint. You're going to have to factor this. If you want to substitute in the a's, you would make a tan theta. So this would be 4a squared plus 5a equals 6. I would subtract the 6, so they're all on the same side. And then you can do first and last. So 4 times negative 6 is negative 24. The product, or the factors of negative 24 that sum to 5 is positive 8, negative 3. So I'd get 4a squared plus 8a minus 3a minus 6. And then you want to factor by grouping. Take out a 4a here, and I get a plus 2. Take out a negative 3 here, and I get a plus 2. So a plus 2 times 4a minus 3, is it factored? And then you want to bring back in your tangent theta. So this would be tan of theta plus 2 equals 0, and 4 tan theta minus 3 equals 0. So then I subtract and I get -2. And this is one of those things that it's not that it's no solution. There is a solution. That's just not unit circle based. So not unit circle based. So if this happened on your quiz, you would just write, it's not, you can't find it without the unit circle because you're not going to have your calculator. If that was sine theta equals that, now there's no solution because sine and cosine can't be less than -1 or bigger than 1. Then the other side, for tan theta equals 3, divide both sides by 4, tan theta equals 3/4. Same thing, not on the unit circle. It's not that there's no solution, it's that it's not on the unit circle.
What contingent are you move? Like, if you
Tangent has no restriction.
so it could be-
Tangent is, yeah, tangent and cotangent can be anything. Because you're basically, so, like, think about what tangent is. Tangent is, excuse me, opposite over adjacent, right? On a triangle. There's no restriction on opposite over adjacent. This opposite could be bigger than the adjacent side could be bigger than the opposite side. There's no restriction. Sine and cosine is, sine is opposite over hypotenuse. So if I say that's bigger than 1, I'm saying the opposite side is bigger than the hypotenuse, and the hypotenuse has to be the biggest side. So it can't work. And the flip of that for secant, God bless you, and cosecant is that it can't be bigger than, I mean, it has to be bigger than 1 because of the same reason. You can't say that your opposite side is bigger than your hypotenuse. It doesn't work. It has to be the other way around.
That's the same for like cosecant and
So like sine and cosine are from -1 to +1. They're in between -1 and +1, okay? Or in interval notation would be -1 to 1 with a bracket on it. They're in between -1 and +1. It can be -1 and +1. For cosecant and secant, it has to be greater than or equal to -1. Nope, sorry, greater than or equal to +1 or less than or equal to -1. So they can be 1 because at like pi over 2, cosecant would be 1. Or it has to be bigger than it. It can't be smaller. They're opposites of each other or reciprocals of each other. All right, from this page, you're good. From this page, so 17 had secant and tangent x. These are both raised to the first power, so I can't substitute anything in. So this is when you want to square both sides of your equation. If you don't, like if you square the left side without moving the tangent to the other side first, you end up with like 2 secant tangent, and that is a mess. So what you want to do is move the tangent, and it could have been the tangent or the secant, doesn't matter which one, but because on our identities, it's tan squared x plus 1 equals secant squared x. I would move the tangent to be the side with the 1. So I move this over here and then expand and FOIL it. So I end up with secant x equals 1 minus tan x. And then again, you can't get anywhere if it stays to the first power, so I square both sides. So on the left, it becomes secant squared x, and on the right, if I expand and FOIL that, that's 1 minus 2 tan x plus tan squared x. That would be what you get if you expand and FOIL that. Then I want to replace secant with what it equals. So secant equals tan squared x plus 1. So I do tan squared x plus 1 equals 1 minus 2 tan x plus tan squared x. If I subtract tan squared x from both sides, cancels out, I get 1 equals 1 minus 2 tan x. Subtract the 1, I get 0 equals -2 tan x. Divide by -2, and tangent of x is 0. So then I'd go to my unit circle, and again, this tangent, we only use the top. I would say that where does tangent equal 0, and it happens 2 places. It happens on the right at 0, and it happens on the left at pi. So 0 and then pi. But because we squared both sides, when we do this step, these are the ones you have to check. So you have to check for the extraneous root here. When I take and plug those back in, I get secant of 0 plus tan of 0 equals 1. And then secant of pi plus tan of pi equals 1. So secant is the reciprocal of cosine. Cosine at 0 is 1. Reciprocal of that's still 1. Tangent at 0 is 0. This one works. Secant at pi is the reciprocal of cosine at pi, which is -1. So this becomes -1. Tangent at pi is 0, and that does not work. So we rule out the pi and keep the 0. And because it didn't give you the interval, it'd be 0 plus 2n pi, which is just 2n pi.
Isn't secant of pi -1?
Yeah,
You put positive.
that's secant at 0. This one's secant at pi.
Oh.
Yeah.
So for the actual answer, I thought when you squared both sides, you didn't have to put the +2 and pi.
No, the only time you don't add the interval is if it gives it to you. If it says from 0 to 2 pi, that's when you don't add the interval in the directions. But it didn't. And quiz, some of them are going to give it to you like that, and some of them won't, so you want to pay attention.
Could that like interval be on ones that aren't squared too?
Yeah?
And then also, what would you do then? You said at the beginning if you didn't move the tan.
I don't think you can solve it because you end up with a 2 secant tan.
Yeah, that's
You can't do it.
Oh.
Yeah, so you've got to move them. The only time you can keep them on the same side is when it's cosine sine, because that's like when you square. Actually, even then, no, you end up with 2 cosine sine. You can't. You got to move them. So you got to put one trig function with the 1, and then 1 by itself. Yeah. Jensen.
Why do you add 2n pi and not n pi?
Because you're right. It actually should be n pi, right? This was tangent. Yeah. So it should be n pi. 0 plus n pi, which is just 0. Wait, no, because the pi doesn't work. I'm like, wait, well, there's a reason. Because the pi doesn't work. Because by saying 0 plus n pi, you're saying I can do 0 plus pi, which makes it pi, and it doesn't work. So you had to add the 2n pi there. Okay. Even though it's tangent, because it's one we had to check. You rule out pi, right? So if it's tangent, normally we would do 0 plus n pi. The first n pi is pi, and it doesn't work. You're welcome.
So every time you have to check first.
Every time you square both sides of the equation, you have to solve it, you have to check your roots.
What if you square it or if you
It's the only time, because we're actually changing the value of our original equation. The rest of them we just solve.
but other than that, you push n pi for tangent and cosine.
Right. Right.
So since it didn't work there for the other side, you would do 2n pi.
Correct. Yep. All right, number 19. This time you've got sine and cosecant. Those are not ones that are on my, like I can't use sine squared plus cosine squared, but they have 2 different functions. So you want to change sine or cosecant to be 1 over sine. So this becomes 2 sine x plus 1 equals 1 over sine x. Then I want to get rid of the denominator there. So I'm going to multiply everything times sine x. I want to get this, so this would be 2 sine squared x plus, this gets to distribute to both, sine x equals 1. So this gets canceled. So again, I'm getting rid of the denominator there. Then I have a sine squared and a sine, which means you're getting everything to one side, and you're going to factor it. So 2 sine squared x plus sine of x minus 1 equals 0. Factor it out. You can either do first times last or trial and error like this. It would be a +1 and a -1 here, and then split and solve. So I'd get 2 sine x equals 1, sine of x equals 1/2, sine of x equals -1. And then you'd go to your circle, you'd find everywhere the y is a +1/2, which happens at pi over 6, and 5 pi over 6. And then everywhere the y is -1, which happens at 3 pi over 2. And to all of these, we add 2n pi.
Is there a different way to solve this?
Is there what?
A different way of solving this?
I mean, you could try to give them a like denominator. You can move it all to one side and give them all a like denominator. Yeah.
So we couldn't do the a thing for this? The a squared and then...
Yeah, from here you can. Yeah, I said you can either do the A or you could do trial and error.
Why didn't, when you made 1 over sine and then you multiply it by sine, why wasn't it 1?
It is. That's this one.
Oh, okay.
Yeah. The other side I distributed it. All right, 23 is cosecant plus cotangent equals 1. So again, another time in which they are not reciprocals of each other. You have to square both sides, but you want to move one to be on the side with the 1. So I move the one that's normally with the 1, is what I would say to do. So because it's cotangent squared x plus 1 equals cosecant squared, I move the cotangent over here. So cosecant x equals 1 minus cotangent x. Then you square both sides. So because we're squaring both sides, we're going to have to remember to check. So this would be cosecant squared x equals, and this is 1 minus cotangent times 1 minus cotangent. 1 minus 2 cotangent x plus cotangent squared x equals cosecant squared x. I need the same trig function, and I can't replace the cotangent to the first, which means cosecant's the one we're going to replace. We have to replace cosecant, and it's 1 plus cotangent squared equals cosecant squared. So this becomes 1 plus cotangent squared. And then when you subtract the cotangent squareds, they go away. 1 equals 1 minus 2 cotangent x. Subtract the 1. 0 equals negative 2 cotangent x. Divide by negative 2. Cotangent x would equal 0, which means tangent would be undefined. And that happens at pi over 2. It would be plus n pi. And then these are the ones you have to check. So this is the work over here to check it. When you plug it back in, it works. So I get to keep that answer, which was pi over 2 plus n pi. All right, 25, you had to factor. So when you factor tan squared x minus 6 tan x plus 5, which you could be a squared minus 6a plus 5. When you factor this, you'd get minus 5 and minus 1, and a would equal 5 and a would equal 1, or tan of x would equal 5 and tan of x would equal 1. So the 5 is not that it's no solution. There is a tangent of 5. It's just not on my unit circle. But tan of x happens at pi over 4, and it would be plus n pi because there's no interval. So again, there's a difference between no solution and not on your unit circle. Those are two different answers. Okay, all right. Oh, sorry, go ahead. Pay attention because on the directions here, it says solve for all from 0 to 2 pi. This is like having this as an instruction. So there's going to be times on your quiz when you get that, and then there's going to be times in the quiz when you don't have that. When you don't have that, so if it's not there, no interval given, that's when you add on your interval. So for sine and cosine, you add 2n pi. And for tangent, you use just quadrants 1 and 2, and you add n pi. If it gives you the interval from 0 to 2 pi, you use the entire unit circle except for 2 pi. So that is where you don't add on the interval, okay? And again, pretend as though, I would say maybe split it in the middle and say that those instructions are for, here we'll go, those instructions, so 0 to 2 pi for up to 7, and then from in here, no interval given. That way you can practice both sets of instructions, okay? The ones on the bottom are not going to give you the interval, so like they're following the directions on the top, the answers, but make sure these have your plus n pi's or your 2n pi's, what you need here. That way you can practice it.
So if it gives you the interval,
You use the whole unit circle, you don't add.
Okay.
Yep. Yeah, sure.